So this time, uh, we are going to solve a sample problem on indeterminate members. So, once again, pag indeterminate, need tawag additional equation. Ito, compatibility equation. Okay. The shaft in the figure consists of a 3-inch diameter aluminum segment that is rigidly joined to a 2-inch diameter steel segment. The ends of the shaft are attached to rigid supports. Take note, rigid supports. Calculate the maximum shear stress developed in each segment when the torque T equal to 10 kips-inch is applied. Use G equal to 4 times 10 to the 6 psi for aluminum and 12 times 10 to the 6 psi for steel. So, if you will analyze this one, okay, ang support rigid. So, it's impossible na mag-rotate siya, okay, or ma-twist siya. Okay? And there are two unknowns. Reaction sa or resisting torque sa aluminum and then resisting torque sa steel. It's different sa previous problem na when you cut a section, makuha dahil nimo ang resisting torque. Dire dili. Given ang 10. So the question is, out of 10 kips inch, how much is being resisted by steel? How much is being resisted by the aluminum segment? So ano na? Eh? Let T1 be our resisting torque for steel and then T2 for aluminum. And since counter ne, atong resisting torque will be clockwise. So, we have to ano, di ba? So, we need two equations. So, first is equilibrium equation. So, sa axial, we sum up force or we sum up moment. But for this topic, we will sum up torque. So, summation of torque be equal to 0. And it's obvious that T1 plus T2 is equal to T. Yeah? Dapat ang sum anin duha is equal to 10. Mo man na yung applied. Mo ni resisting. So, para makuha na to ang stress, we need the value of T1 and T2. So, we need an additional equation. This will be equation 1. Equation 2 will be taken from our compatibility equation. Sa angle of twist nga restriction. So, if you will focus on this one, ang support rigid, so dili pwede ma-twist. Ang junction sa aluminum o steel, rigid ang pag-attach but it doesn't mean na dili siya ma-twist. Ang attachment is rigid, pero mo-twist niya siya. Di ba? Oh. Ang kondisyon lang ani niya, kung rigid siya, it means na ang amount of twist sa aluminum will also be equal to the amount of twist sa steel kay ang connection rigid man. So, they will rotate as one. Same ang ilang rotation kay ang connection nilang duha rigid man, rigidly attached man. So, kung ma-twist ni siya og 5 degrees for example, ang sa steel 5 degrees also. Kay rigid man ilang attachment. Diha ato compatibility equation that the angle of twist of aluminum is equal to the angle of twist of steel at the junction. Ba? Okay. Kini siya. Theta of aluminum equals theta of steel. Kisa din sa support, wala tayo theta din. Rigid man eh. And then you replace this one by its expression. TL over GG for aluminum equals TL over GG for steel. And then you replace aluminum T2 6. Now, sa values, you may not convert. Like kini, 6 feet, kini 3 feet. Pwede rin, dili i-convert, kaya compare lang man ka. It's useless to convert. Okay? If you will multiply this one by 12, you will also multiply 3 by 12, so it will just cancel out. So, TL over G, TL over GG. And then you cancel terms like pi over 32, cancel, 10 raised to 6, cancel, 3 and 12, cancel, na 4. 4 and 4, makancel. So, what remains are 6, 3 raised to 4, and 2 raised to 4. So, if you will cross multiply, 3 raised to 4 is 81. And then 6 will be multiplied by 2 raised to 4. 2 raised to 4 is 16 times 6, 96. So that would be 81 over 96. Reduced by 3, that's 27 over 32. So T2 equals 27 over 32 T1. This will be equation 2. And next is you substitute equation 2 to equation 1. And you will get T1 equal to 5,423.73 pounds inch. Subtract this one sa 10. Keeps man So 10,000 siya. 10,000 minus 5,000, and you will get T2 equal to this one. Okay na. Uh, we can now solve for the maximum stresses. Direct substitution na lang tayo. So, torque ra ang problema niyo. For aluminum, and then steel also. Kana lang. So, kung maka-encounter ka problem, focus on the connection. And if it's rigidly fastened, then equal ang angle of twist there. So, di tama ng discussion nito sa shaft, sa torsion. Torsion sa shaft bale. And just solve other problems. I will give you additional problems to work on para ma-apply ninyo. Okay? For practice. Okay. So, the other material subjected to torsion is a helical spring. Okay, kining helical spring ba? Kini. Oh. Nganong torsion isa? Kung imagine ninyo, kining P dire, pag act anang P, kini na portion, originally kung puro na siya horizontal ba? So, kini siya nga member, paubos downward, while kini siya pasaka. So, kini na portion dire, na din twisting eh. Yeah? I hope may imagine na ninyo. Try to make use of your hands, left hand or right hand. I-form og parang semicircle ba. And then, i-pull nimo imong thumb downward, and then ang index finger nimo upward. And ma-sense nimo na murag na torsion sa may kanto dapit. Inaanal. Okay? So, when close-coiled helical spring composed of a wire of round rod of diameter D, wound into a helix of mean radius R where the number of turns is subjected to an axial load P, produces the following stresses and elongation. So, the maximum shearing stress is this one, 16 PR over pi D cubed, 1 plus D over 4R. You can find in FB a mnemonic on this, no? I forgot totally the sakto na. Like 16 paper roses pinadala sa tatlong dalaga. Yan ba? Samok mo to. Okay. So, why not memorize na lang? Eh? Hmm. Yan. So, instead na 16 paper roses, payman, pinadala sa tatlong dalaga. Samok, di ba? Dili tayo ng mga gugma-gugma, ha? So, you just memorize this one. 16 PR over pi d cube 1 plus d over 4r. Actually, ang derivation na ni is, dire na point, ang shear stress niya is a combination of direct shear stress o torsional nga shear stress. Katong P over A na stress o torsional na TR over J. I-add nimo to and i-simplify mo niyang result. Uh, I can show you the derivation of this. Picture lang later. Okay? So this formula neglects the curvature of the spring. Kini ba? Kini curvature sa spring. This is used for light spring where the ratio d over 4r is small. Conservative din siya ng formula because gigamit niya ang katong TR over J nga formula which is used for circular shaft. Pero take note, ang circular shaft na to, straight man to. Whereas sa spring, curve man eh. So katong line nga AB, bitaw, kung mo deform siya, laylay ang deformation sa line opposite niya. Example, just imagine mouse, just follow the mouse movement. Naka-circular na cross-section. Tapos kini na part na kay boundary. Muni mong line EB, di ba? Sa opposite end niya, napo kay kumbaga morag mirror sa EB dito. Kung imo to siyang i-twist, ang katong B nga ma-move sa B prime, same ra po diri pikas. Ang B diri ma-move po sa B prime. Same lang. Because ang length sa EB initially equal raman. Oh, pero for helical spring curve man eh. Kung na kay duha ka EB inside and outside, ang length sa EB sa sulod mas mubo kaysa length sa EB sa gawas. So ang amount of deformation nila is different. Dili siya equal. Di ba? So conservative ni siya, giniglect niya ang curvature sa spring. Kaya kato formula nga TR over J is based man to siya sa giderived na formula based sa straight na shaft. Kini curve man eh. So gi-correct siya ni AM wall. AM wall considers the curvature of the spring. This is a more precise formula. And it is given by this one. Nana po ni siya yan nga 16 paper roses pinadala sa tatlong dalaga. Ito. Bumili ng 4, nahulog ang isa. Ano ba? Bumili ulit ng 4, nahulog lahat. Ano sawa? Tapos sinagot nung June 15. Mga ginana, 6:15 ba? Samok mo na. Diba? So anyway, if you want that one, pwede ra. No? If not, then you just memorize it. So, ang M, mo ni siya. 2R, this is mean diameter or diameter gid sa spring mismo. While ang D is diameter sa wire. Katong wire ang gigamit. Pero kini 2R diameter man eh. Diameter gid sa spring. And where M is called the spring index. And kining ratio na 4M minus 1 over 4M minus 4 is called the wall factor. So, empirical na kay basta decimal, empirical formula. The elongation of the bar is this one, 64 PR cube in over G d to the fourth. If you can find a mnemonic on this, plus 10 mo. Kung makita mo patsadahay o kuan, that will be your assignment. Patsadahay o mnemonic ani. Eh? Sige. Take note ha. Assignment na. Pangita og mnemonic ani. Code. Uh, ang pinaka the best of code, i-post na ako FB. Top 3. Tagaan ako reward. Ha? Tagaan ako reward. Take note on that. Okay, so makita nimo sa formula, makita nimo sa formula na like for example, M, given man eh. R is given, D given. So, based sa formula, M, P ray mo kwaon. So, pag masolve nimo ning resisting load, nakuha nimo ang stress. Same ra sa elongation. Diameter given, modulus of rigidity property given, and number of turns given. And then R, mean radius given. P ra gyapon. If you can solve for P, then makuha dayon nimo ang delta. Inana ra kasayon ang deformable bodies. Tag-isa ra ang kwaon ba? Substitute mo na dayon. Makuha na. Diba? Okay. Sige. I will be solving 2 problems only and the rest gaan man ako og practice problems and come on na dayon na. And make this one as your guide na lang dayon. Sige. Compute the maximum shearing stress developed in a phosphor-bronze spring having a mean diameter of 200 millimeters and consisting of 24 turns of 20 millimeter diameter wire. When the spring is stretched 100 millimeters, use wall formula and G equals 42 gigapascal. Ayaw ka interchange ha. Mean diameter ni. Diameter yung sa spring. Dako oh. Walang diameter sa wire, 20 lang. Okay, so compute the maximum shearing stress. So, kinahanglan ka og P, di ba? So, amo na to given. Mean diameter. So, makuha na to ang mean radius ani 100. Number of turns, 24. Diameter sa wire, 20. Given ang elongation, 100. And then G, 42. So, para makuha na to ang shearing stress, need na to ang value sa P. Walay P dire, pero given ang delta. So, we will use this one, this value, substitute sa formula, we can solve for P. Mo ni ang formula for stress, and formula dahil siya sa spring deflection. Now, given man ta og delta, mo na atong gamiton dire. So, substitute na to. Kana, okay, 164 P, mean radius 100 cube, number of turns, and then G dayon D to the fourth. And then simplify, use your calculator. Na kay P equal to 437.5 newtons. After this, substitute na nimo sa formula sa stress, mao na dayon. So, solve for the maximum shearing stress. Kana, sa nimo kuha ang mm is 2r over d, or simply mean diameter. 200 over diameter of wire, that's equal to 10. So, substitute na nimo diya 10 diameter, mean radius, and then ang katong na solve na to na P. Okay, this one. And one ang maximum shearing stress. So, yun na, di ba? The other sample problem is this. This is similar to axial. Yan, naka-encounter naman yun. Similar na sa axial. Instead na rod ni spring itong gamit. Okay. Spring siya. Instead na rod. Pero ang analysis is the same. Magamit na compatibility yan eh. Di ba? Sige. A rigid bar pinned at O is supported by two identical springs, meaning pareha sila diameter, pareha sila number of turns, pareha sila og G, what else? Diameter of wire given, although given, pero pareha gyapon identical man. All properties equal sila. Each spring consists of 20 turns of 3/4 inch diameter wire having a mean diameter of 6 inches. Determine the maximum load W that may be supported if the shearing stress in the springs is limited to 20 KSI. Bale, ang shearing stress daw in the spring is limited to 20. Ang 20 KSI, we don't know kung ahana. Kini ba na spring o kining isa ba na spring? Dili makaka-assume nga magdungan sila. Nga ma-reach nila ilang limit at the same time. O it's either una niya ma-reach ang limit or this one. So i-test na nato. Okay? Pwede po nimo, you can make a guess if you want. Kana kung anad na yugay ka. Pero kung beginner ka, i-test na lang nato. Okay? I-test na to. Assume na to nga na-reach niya yung limit nga 20. And then compute for W. Next, i-test na to nga na-reach niya ang limit na 20 KSI. And then solve for W. And then select dayon ta. Which of the two answers is the maximum value? Ana ta, ha? Ngayon, diameter, no? Mean diameter, number of turns, diameter of wire. Yan. Condition, shearing stress in each spring is limited to 20 KSI. Pero, dili simultaneous or dili at the same time nga may experience nila ang maximum value. So, let's identify forces. So, na force dire P1 and P2. So, nga na yung direction. Kung imagine nimo pagbira aning weight ni W, this spring will be stretched, mainat man di ba? While this one will be compressed. Therefore, compression siya, while this one is tension. Mao na siya nga ang force dere downward kay iya man ning giduot. Ay pasabtahan nga yan iduot downward ano. We all know naman ta sa convention nga pag compression it is towards the joint, di ba? Or towards the point. While ang tension away sa point. That is why ang atong P2 away na siya. Palayo ba? Mo na itong point. Away na siya. While this one, mo na itong point towards sa point. Ana siya. Kay compression mo na siya while this one is tension. So, condition of equilibrium, mo may una na to. Be systematic in your analysis. So, una, equilibrium equation. So, may makuha mo dire. Do not sum up force kay ma-appeal ang reaction. Instead, sum up moment at the support O. Okay? And you will have this one. P1 times 2 counterclockwise. P2 times 4 counterclockwise. Minus W times 7 clockwise. Inana. So therefore, if you want to solve for W, we need the values of P1 and P2. Diba? Sige. This time, ato nang i-test dayon. Yung mga ito yung equation mo. So, i-test na to, ato sang kwaon, compatibility equation. Ang compatibility equation na to, wala man tayo angle of twist dire, kaya dili man siya shaft. So, same din siya sa kato axial. Ipa-deform na to. So, di ba? Ipa-deform na to. So, what will happen to this bar kung naa ni weight? Inigbira niya na, di ba kini nga point will go up, kaya makompares man eh. Well, this point will go down. Mao ni siya, di ba? Nakay P1, di ba? Na P2. So, ang imong bar karon mo ni yung deform shape ay nana. Oh, di ba? And kaya yon, mo ni ang spring na deformation. Delta 1, and then this one, spring din as a deformation for spring number 2. Diha ta magkuha og compatibility nga equation by ratio and proportion. Oh. So delta 1 over 2, 2 man eh. So over 2 siya. Delta 2 is to 4. Ano 4 niya. And then simplify, natay na ni. 2 delta 1 equals delta 2. And i-replace na ito ng delta katong 64 PR cube n over g d to the fourth inana. This one. And then mo cancel ta. So cancel na ito ng 64. Cancel na ito 64. Cancel na tong R. Same raman. Cancel na ito ang G. Cancel na ito ang D. Di ba? So ang bilin din will be 2P1 equals P2. Muna itong compatibility na equation. That's equation 2. Diba? So, i-test na to. So, first one is, let stress sa spring 1 be equal to 20 KSI. Iuna na to siya. I-allow na to na maximum ang may experience aning spring 1. And, since yung problem, wala gito nakabutang na use Walls formula. Therefore, we will use the basic formula. Kana, ano? Basta wala na ka-indicate sa problem na use Walls formula sa basic. Stress 16 PR over pi d cube. Diameter na to 3/4. 1 plus d over 4r. Ang atong mean diameter kay 6 man. So ang mean radius na to 3, di ba? Amo ni sa 16 PR 3 ni sa 1 plus d diameter sa wire 3/4 over 4r. And then simplify, makuha ni mong P1, 519.75 pounds. And then you go back sa equation 2, makuha ni mong P2. Bali, P2 is 2 times P1 times 2, eh? And then, knowing P1 and P2, you go back to equation 1, makuha ni mo ang W. So, muna itong first value, 742.5. Okay? Sige. Second is let stress 2 equal to 20. Ang spring number 2 nasad. Same nga, kwan. Balik lang niya. Pito lang tayo niya. No? Okay. Same formula. 16 PR over pi d cube quantity 1 plus d over 4r. Natay P2, 519.75. And then from equation 2, yun nakamatay P2 na 519, i-divide og 2, that would be P1. And then from equation 1, natay 371.25. Therefore, ang maximum value ani is katong pinaka-safe, which is the smaller one. So, ang katong sa first nga condition, ang W ato kay 700 man. 742.5, no? So, ang pinaka-safe is kini. 371.25. The smaller one, the smaller value. And sige naman tag-discuss o problem ani ba? Nga basta inanay gani maximum load it should be the smaller one, pinaka-safe. And I hope na you'll be able to, I mean, you can explain ngano ang gamay na value kwaon, di ba? Na-illustrate naman na before. Okay, so this ends chapter 3. So, what you need are more problems to work on, and ihatag na ko na sa inyo para ma-practice mo. And from time to time, refer to the video, to your notes, para kuan, para mag-guide mo. And I think makuha rin na nila.